Hello, students. Let's look at lesson 2.0. For lesson 2.0, you're going to need to remember the pendulum lab. Please remember that when a pendulum swings back and forth, one cycle is from the starting position at angle theta to the other side and back to the starting position. Theta is a Greek alphabet letter. Let theta stand for the angle that you pulled the pendulum back to. That's angle theta, the starting angle. When the pendulum returns back to the starting position, it has been one cycle. Please look at my diagram. Here's the pendulum stand and the swinging bob. When the bob or pendulum has gone over and then back, that is one cycle. The starting angle is theta, and that is the amplitude that you'll see later when we draw the graph of the wave. There are some other terms that you'll need to learn for lesson 2.0. Let n equal the number of cycles. In our pendulum lab, we let the pendulum swing back and forth for 10 cycles. So for our pendulum lab, n equaled 10 cycles. Let little t stand for the total swinging time. In our pendulum lab, we measured the time t, the total time. But in our pendulum lab, we wanted to calculate the period of the pendulum. Please remember that we let capital T stand for the period. And the period was the time it takes for one cycle. Please make sure you understand and have that in your notes. The time it takes for one cycle. In our pendulum lab, we let it swing back and forth 10 times to reduce human error in using the stopwatch, to reduce the reaction time. One student measured that 10 cycles took 12.52 seconds. So in that situation, little t equals 12.52 seconds. N equals 10 cycles. To find the period, we had to use this equation. Period equals the total amount of time, which was 12.52 seconds, divided by the number of cycles, which was 10 cycles. When you divide, you get 1.252 seconds. So that is the time it takes for just one swing. After the pendulum lab, we started lesson 2.0. We began by talking about frequency. Frequency is the number of full cycles per 1 second, and we can represent frequency with a mathematical equation. F equals n over the total time. Let's try an example of frequency. The student who measured 12.52 seconds wanted to calculate the frequency. In that case, little t was 12.52 seconds, and the number of swings or cycles, the number of cycles was 10 full cycles. So in order to get the frequency, we would need to divide 12 cycles by time of 2.52 seconds. Now, I could do this math in my head, but it would take me all night, so I'm going to get my calculator. Ten divided by 12.52. Go ahead and get your calculator and do it as well. I hope you have your answer by now. Don't just copy mine. I'm waiting for you to get the answer done. I'm not going to do it for you. Hurry up, get your calculator. Okay, you can check your work with me. I got 0.7987 swings per second. This SEC right here means seconds. Let me write that again over here. Frequency equals 0.7987 per second. The units are per second. There's a special name for these units per second. That equals hertz. And in lesson 2.0, we learned the definition of hertz. 1 hertz means 1 cycle per 1 second. This fraction line right here can be read as per. When you have a fraction, it means to divide or it means a rate. So this is a rate of 1 cycle per second. If your frequency is 2 hertz, which is abbreviated as Hz, if you have a frequency of 2 hertz, then that is 2 cycles per 1 second. If you have a frequency of 4.5 hertz, well, you get it. That's 4.5 cycles per second, and so on and so on. What if you had a number of only 0.3 hertz? What does that mean? Can you have a frequency less than 1? Yes, you can. 0.3 hertz means that only 30% or 0.3 cycles have occurred in 1 second. So that means the cycle takes longer than a second. Okay, now you are an expert at period, which equals the time it takes divided by the number of swings. Make sure you understand what period means. When you divide the time it takes by the number of swings, you get the time of 1 cycle. Now you also understand frequency. And the mathematical equation for frequency is the number of swings divided by the total time. The meaning of frequency is how many cycles per second. Make sure you understand that and can answer that on quizzes. How many cycles per 1 second? Or it could be per minute or per hour if you're looking at other rates. But those are frequencies. Okay, what do you notice about period and frequency? Period equals T divided by N, and frequency equals N divided by T. They are reciprocals. T divided by N flipped over is N over T. That's called a reciprocal, and you might remember that from fractions. Another word is an inverse. T equals the flipped over of frequency. That's called an inverse. And we can write that as 1 over F. Let me prove to you that that works out the same. If I substitute in the F, which equals N over T, then I get T equals 1 over, and then put down here F. F is N over T. That is the same as this T equals little t divided by N. I'll prove it to you. First, I'm going to write my fraction this way. So 1 divided by, I'll write it this way, 1 divided by N over T, which is N divided by T. Now, please remember that when you are dividing by a fraction, you need to use keep, change, flip. So that equals 1 times little t over n. Then multiply straight across. You can draw the denominator there. Finally, I get t equals little t over n, which is exactly the same as our original definition. So you see, period equals 1 over frequency. Go ahead and pause the video and try to do this yourself in your notes step by step. And the last thing I want you to learn from lesson 2.0 is that frequency is the inverse of period. Period is t divided by n. Frequency is n divided by t. So that is the inverse of period. And it can be written as frequency equals 1 over capital T. That is the reciprocal or inverse, however you want to say it. Okay, let's summarize the 4 equations and variables that you need to know from lesson 2.0. You need to have these memorized and be able to use them. Little n equals number of cycles. Little t equals the total time of those cycles. Capital T equals period. Period stands for the time of one cycle. And there's an equation for period. Period equals the total time divided by the number of swings. Frequency, we let little f stand for frequency. Frequency is the number of cycles per 1 second. How many cycles occur in 1 second? Number of cycles in 1 second. And frequency equals little n over little t. We also saw that period and frequency are reciprocals. So we can write another equation. Period equals the inverse of frequency, which means 1 divided by frequency. And frequency equals the inverse of period, 1 over t. Please be ready to use these equations on the quiz.